Jerry,
Uh,
you want to give us your talk?
uh, well, I have to sort of revise it on the fly here. Uh,
Yeah, that's okay. That's that's why we do this.
uh, yeah, let me first say that I really think that I'm disappointed that Ram is not here because this all centers around the notion of the nature of language and how language is being used to um, in human cultures, and I have to go that broadly, in human cultures, which depend on the development of languages in order to have internal communications among the population. And so this notion of language per se is what's really under scrutiny here. And I really like Lauren's work uh, in that he clarifies very nicely how his mind works under these circumstances, how his values are applied to different situations, how his individuality and his beliefs relate to how he interprets languages. And he's willing to be very crisp and clear insofar as the limits of language go in expressing himself. And I find this to be wonderful, Lauren. I really think you're a rare bird in in this discussion of languages. um, and so that part of it is uh, really, I thank you in this context, uh, Jason, for your contributions in organizing these, because they really are very helpful to me in my own thinking, in my own research, in my own development of what I'm trying to do. So
Of course,
that's
of
good.
course.
And
That's the purpose.
right, exactly. Uh, but so last night I listened to a professor of mathematics from Caltech um, describing her work with uh, the linguist from Boston at Harvard. His name escapes me at the moment. Who's a famous linguist at Harvard? Uh,
No.
Chomsky's at MIT, or
Chomsky.
was.
Oh, well, yeah. Chomsky. Robert, I thought he was at Harvard. Anyway,
No, his whole career is at MIT.
okay. So anyway, Chomsky has his notion of languages and constructions of languages, and that it's had a huge influence on the development of linguistics since the 1950s. And in my own personal work with development of the languages for chemistry, I found Chomsky's ideas to be absolutely ridiculous in terms of how the language of chemistry has developed and evolved. And from the notion of atomicity and from the facts of the world. And this is where I connect with Gerard's concerns about the facts of the world and in the relationship that how the chemical language works with respect to those facts of the world. And so in that context, this professor from Caltech, a mathematics professor no less, who has worked with Chomsky now for many years, defended a notion of why Chomsky's views of language are superior to ChatGPT's notion of large language models. And so this question of large language models is what she was attacking throughout her, roughly half-hour presentation. And she has several other YouTube videos on. So you want to follow up on it, I can post her name on it. where she does a very direct mathematical confrontation with ChatGTP and the large language models. And so it's well worth your time, particularly if you believe in Wittgenstein and his perspectives of language, to follow up on her analyses. And the reason she's harsh, and this is where the link with chemistry comes in, the reason that she's so harsh about ChatGTP is because it's based on, from a mathematical perspective, a huge corpus of data, and then 3 matrices, which she gives 3 different names to them, but they're just simple matrices. They're not affective renditions such as Lauren has given. So there are 3 matrices which she finds to be inadequate to explain the tree structures of grammars. So that her Chomsky's views, in her perspective from mathematics, is simply a mathematical tree that is used to construct the language of sentences. So then to create meaning out of this, she starts at the leaves of the trees and merges them together. In other words, independent variables that are merged together to become, shall we say, something different. That is the branch point for the leaves, and then merging upward through the structure of the sentence. And in that context, each of the leaves of the tree is independent of one another. And so this would require that the sentence as a whole, and Robert, your term here, the terms of the sentence would all have to be, in some sense, independent of one another, such that you could bring them together as a merging of the tree up to the stem of the tree or the base. So this is very solid mathematics from her view of Chomsky's work in his construction of terms into sentences and into language. It's relatively simple mathematics from her perspective. Now, she's a full professor of mathematics at Caltech, and so you have to take her views quite seriously in terms of the mathematics of Chomsky's perspectives, and which bear no relationship at all then to the facts of the individual terms. And let me put that again, so that from her perspective of Chomsky's view of language, there must be an independence of these terms in order, before you can merge them into a new term. In other words, composition of variables, if I want to put it into mathematical context. So that's there for the public to observe and to compare with today's presentation by Lauren and with Nagy's interpretations, which are quite similar to the sense in their, and so distinctive from the axiomatic methods of mathematics. And that's the real point that I wanted to point out. Now, how does this relate to my own work with the language of chemistry? That's the issue that I now would like to perceive, or just briefly touch upon. And so the idea of chemistry goes back to early parts of Western civilization. The Greeks coined the term atom, and the notion of being invisible particles of matter grounds the concept of atomicity. For Aristotle, there was an infinite number of invisible particles. Around 1800 or so, Western civilization reduced that number infinite indivisible particles to, well, just a handful of invisible particles. And eventually, with Mendeleev, decided that in reality, the material world really has only 92 of these individual particles that are invisible, indivisible, and intrinsic to nature. So that from a mathematical perspective, we now can consider the development of the language of chemistry as how do we relate these 92 terms from Robert's perspective, 92 terms into sentences that are meaningful with regard to the observations that you make in the laboratory. And so that becomes the question of the mathematics of chemistry. These are 92 numbers, and they are ordered in a certain way in the table of elements. And that ordering in the table of elements becomes part of the language of chemistry, and how these terms, which start out from purely physical observations, all right, and I would say in terms of confidence of the facts, is that the table of elements is represented universally in all cultures with the same symbols. So they may use different words for the same chemical elements, but the same chemical symbols are used, and the logic of how those symbols are used in every language is the same. And this, of course, is my interpretation would be that the facts are the same with regard to the nature of water, if you would, or the nature of gold. No matter what culture you're in, the facts are the same. So this comes back to Girard's notion of what's the origin of the facts in the language of chemistry? Well, the origin of the facts in the language of chemistry is sensory observations. There are perceptions of what we experience, but they're definitely sensory. They're definitely external to our bodies, so that this introvert-extrovert issue becomes very profound in how we work mentally with chemical symbols, so that all the symbols must exist externally and in the table of elements as independent agents, if you would. So part of this internal-external limits and bounds the language of chemistry to those objects in the external world which you can sensorily detect. And if you can't detect them, then they're not in the language of chemistry. So there's this very severe boundary condition that exists for the language of chemistry that is not present in mathematics, and it's not present in ordinary semantics, and it's certainly not present in Chomsky's notion of independent variables being merged together. So what I'm saying is that the language of chemistry has developed now, it's now 150 years since Mendeleev put his table together, that becomes the boundary conditions, basically, for the language of chemistry. But is now developed into a very, very powerful language based on the analytical methods that determine the components or constituents or the terms of the language of chemistry. And so that the severe restrictions of the initial set of terms limits the nature of the compositions of the possibilities. Now, because of the nature of compositions and if you would, the infinite ways you can construct sentences from a language point of view, the question then becomes of, well, how do you relate the meanings of the terms to one another? In other words, so I have sodium and I have gold. and no one says sodium gold. The two terms don't go together. There's a conflict there. The same way with sodium and potassium. Give another down, or sodium and calcium. These are all first row elements that they don't combine with one another. So this is a different sort of constraint on the language. On the other hand, there is the freedom to say sodium chloride, sodium fluoride, sodium bromide, sodium iodide. So these are all terms where they're combinatorial possibilities. And it turns out that the sodium and the monovalent elements are on the far left, and the halides and whatnot are on the far right, except for the inert gases, which are on the very, very far right. And so all of this then says, well, there's a lot of structure to the language of chemistry, depending on where the positions are in the table of elements. And so that position in the table of elements then becomes a crucial part of the language of chemistry, and constrains the compositions of sentences. It constrains the mathematics of chemistry in very profound ways. And if I look at it from that perspective, my entire career for the last 35 years or more has been, what the hell is this constraints all about? Why are these constraints there? And why did they limit the language of chemistry, but not the language of physics or the language of mathematics or ordinary language? And so there is so that's the one way I can look at Lauren's sort of self-analysis of how I use the language of chemistry. And I'm repeatedly using the notion here of chemistry because I want to see it as a separate and distinct set of terms, a separate and distinct set of verbs, a separate and distinct set of predicates that are all related back to the table of elements. So I'm saying that the structure of the language of chemistry depends very directly on the structure of the table of elements, and that these structures must somehow be brought together in the terminologies of chemistry, in the language of chemistry, in the words of chemistry. And so that this sets out then the separation of language of chemistry in a different way than which the language of German is separate from the language of French, which is separate from the language of Chinese, or that sort of thing. And so it's a different notion of language that the chemical science bring to the community, to the modeling community particularly. Now, I'm going to stop, I think, in saying one more thing, or two more things. So recently I've succeeded in solving, in my own mind, internally, in my own private language, not Wittgenstein's language, okay, what is the connections between the factors of the grammar of ordinary English sentences, the grammar of mathematics, and the grammar of chemistry. These are three different grammars, at least three different grammars. And now if I want to do the fourth one and talk about the grammar of biology, I got a special problem, because biology has sex and chemistry doesn't have sex. And so there's a very clear distinction between the terminologies involved here. So why does chemistry not have sex?
It has protons and electrons.
Yeah, and neutrons.
Exactly.
So the point is that well, anyway.
But the ancient Chinese invented this paradigm for the yin and the yang. And that was purely mapped into your sex notion and the neutrons versus electrons thing.
Okay. Oh,
But
I have a more technical answer, Jason. But anyway, just having a little fun with you all. That's all. So the issue of the nature of a chemical symbol comes to the front and fore as a fact. And the simple point of the language of chemistry is such that these symbols are constants. You can't change them. So, well, you can combine them with other symbols. You can relate them to other symbols. You can make sentences with them from other symbols, etc. They themselves have their own personal identity, their own ipsity, if you would. Their own ubity is another word, their own thing. Now that, I want to use the word ubity here. It's a Latin term that expresses the whereness. Okay, and so this notion of whereness becomes critical to number one, the identity of the term, the individual elemental term in the table of elements. So it's at some position. Where is it in the table of elements? Well, it's there, row 3, number 4. That's the whereness, the ubity of the term in the table of elements. That ubity within the symbolic framework of the table of elements is preserved under the conservation laws of physics. In other words, the conservation laws of Newton and Coulomb are conserve matter, and they conserve the terminologies within chemistry, and the language of chemistry is built around this conservation of ubity within the table of elements. And this conservation process then is what is used to construct the language into connectivity of the terminologies. So the connectivity of the terminologies is related to the ubity of the positions in the table of elements, and these then are how the chemists form sentences in the language of chemistry. And this is then subject to determination in the laboratory. So you always have a validation method in the analysis of chemical substances by doing it in the laboratory. And if the laboratory turns out your chemical hypotheses are wrong, then you can't use that in the language of chemistry anymore. So you have, and you may find this to be a highly abstract thing, but it's really, really very critical in the sense of if you have a new drug molecule with say 47 different elements arranged in a particular pattern in it, then that ubity is absolutely essential to demonstrate to the satisfaction of the regulators that this is what you say it is, that this is a factual matter, that you can produce this particular entity, this particular substance matter, this particular term, if you would, in a reproducible way such that it gives you the results in the human populations that you expect. And that then, of course, it moves you wholly into the language of biology and the notion of medicine and how medicine is practiced and when is a drug result reproducible such that it cures diabetes or cancer or whatever you're trying to influence in the science of medicine, or I should say, not say the science of medicine, but the artful practices of medicine depend on the ubity of drugs in the language of chemistry. I'm going to stop there and say that, last year was the most exciting year of my life in that I think I've solved this mystery. And I think that I put together that in a useful way now. And that's really all I want to say here about the 10 minutes that I said I would give you or contribute. But I have a couple of suggestions. One is that we get Ram involved because Ram should be a valuable
I will send
contributor.
him. I will send him the video. No problem.
Okay, but particularly, I would suggest that we schedule another session where at least three of us look at the professors, the Caltech professors, math professors' analysis of Chomsky and large language models, and at least three of us, and I would be one, and I would hope Lauren would, and I would hope Ram would be one of the other discussants, to just agree to criticize her presentation.
I want to assure Jason that I haven't forgotten my suggestion. I was in touch with Jason, I guess in December, concerning a presentation or two that I could make. And it didn't, obviously they didn't happen in the first half of January, but I just wanted to confirm to Jason that that intention has not disappeared. And it's just a
No, no, no.
question
You
of,
just need to send a broadcast notice to everybody.
well,
So we
I
set
would
up a
actually send it
time.
to you. I would send it to you because I'm not sure I have everyone's address, but I don't want to do that. And you're the one who will
Mhm.
schedule it. I don't want to do that until I have updated the presentation and
Okay.
rearranged it because I know that from seeing Jerry's presentations uh, live and on YouTube, I know that it's not a problem if they are over 10 minutes. I could go on for much time over 10 minutes. And I would, in fact, one of the I valorize this place here because it's one of the few places where it would be possible to do that. And
Plan a
so I would
20 minutes. Plan
an
a 20
hour.
minute
Jerry
talk.
talked for an hour once, if I recall correctly, and it was
Now you
fascinating.
have to offer a course. We can ask for a course,
No,
one
no,
on one or
no,
some
a
topic,
course is 12 weeks, 3 hour, 2 or 3 hours a week. No,
mini
not
course.
talking about that.
Oh,
But
but there's semantic.
but because it would be the setting out of the foundation of an applied theory of complex systems and then an exposition of the theory of complex systems upon those foundational bases and then its application to one or more cases. It's a little involved. That's all.
Mm.
So
Okay, okay.
Jerry
Let's
Jerry
schedule the
Jerry
new
knows a little bit
sessions.
about
But
it.
let me
let me
summarize a
finish what I
little
want.
bit.
Hey, let me finish my 10 minutes and then you can talk about policy issues and what. So point one was that I suggest this analysis of her paper and her views of Chomsky's because I think everyone would benefit from it in a very positive way in clarifying the nature of complexity. Secondly, as I said, I put together, and I mentioned this earlier, that I was invited to be a guest editor for a volume, special issue in the journal Philosophies. And I have accepted that invitation and issued a call for papers. And I will distribute that to the individuals here.
Mhm.
This call for papers is extraordinarily abstract, and I've done so out of a desire to force people to get out of their comfort zones and to look at the real issues of facts, at least as I see them from a chemical perspective, and in a way that confronts the mathematical issues very directly in the nature of the mathematics that is involved, and basically why we need a new mathematics is what the underlying theme of it is. Why do we need a new mathematics? Others have put forward this idea before and I can give you references to those. So I will distribute that call for papers to the group. Okay. No, thank you very much, Jason.
Sure. Okay. Uh, Lauren, Carol. Okay, Lauren first, Carol.
Okay, I have two comments in response to Jerry. The first thing is AI system, large language models. I suggest, well, no, evidence suggests that a large language model is primarily doing pattern matching.
Mm.
So when it's trying to do math or logic or that sort of technical thinking, it is simulating it. And it will not simulate it perfectly because it is using pattern matching to pretend to be a logician. And so I think that when a mathematician attacks a language model, it's almost like a category mistake because it is expecting it to do something which it is not part of the architecture. It can do it pretty good, but it's not using that logic. Okay, that would be my comment there. The second thing is on science, the chemistry and the language of chemistry. What you have there, I think it's a really good illustration of the interaction between focusing upon external and focusing upon internal. Because before 200 years ago, nobody had any understanding of the language of chemistry. It was, it actually, you can kind of map it onto these 7 levels of, from believer to controller. So initially, people were just thinking, there's a world out there. There's dirt. I work with dirt. I don't understand it, but I work with it. I do actions with it. And then it's started to internalize as people started to explore and construct internally an understanding of, hey, what is this dirt out there? And now I think we're at the level of civilization builder or controller in terms of having developed a full internal mental grammar of chemistry and using that to be able to properly work with dirt and make really cool things out of the dirt. But you see, there's this interaction between the external world and the internal model of the world.
Let me respond
Carol?
very directly to the science involved there. First of all, let me point out that the notions of chemical elements comes out of really the metals, and particularly gold and silver were mined and developed as commodities, economic commodities as part of the community behavior. And of course, this leads to the whole notion of economics, the metals. And of course, when you learn then how to make brass from cheaper things, and you learned how to smelt iron to give, to smelt ferric oxides to give iron, to go from useless dirt, from your perspective, to a valuable metal which you could make war machines from. Okay, this is all intrinsic to the notion of alchemy. Okay, and this notion of alchemy, as it developed, was a problem of finding recipes of how you wanted to do things. So if you start out with gold and silver and you just melt them and shape them, you don't have to do any chemistry because they come in pure forms. But as soon as you go to brass or tin or lead or copper, you need to smelt these and make them into useful substances. From the dirt, you transform them into useful materials that then become important commodities in the development of the civilizations, particularly their war machines, their farming equipment, these sorts of things that are integral to commodities. Then, and the economic system. The second part of then when became in the medieval times, when particularly the desire to change colors, desire to make good alcohol from wine, the desire to find herbs that would cure diseases or thought to have some influence on disease, led to the development of semantic recipes where materials from the real world were described in a way that you could manipulate them and transform them into stuff that you wanted. And the most important issue here became the fermentation of wine and beer to wine and grains, excuse me, grapes and grains, and almost anything else, fruits, to give alcohol. And it became a really critical part of the commodities of the community. This development of recipes then became an art form. I can make better cabbage soup than you can make better cabbage soup. Okay, become development of, I can dye my shirts redder than your dyes because I use my own private way of a recipe for making the dye. Okay. So all of these things became very pragmatic methodologies, which were captured in semantic recipes. Newton, for example, had more than 3,000 different recipes in his private collection, all of them alchemical recipes. Boyle, who invented the ideal gas laws, he was a physician. He had more than 10,000 recipes in his private library, alchemical. And so all of these then eventually motivated the purification or the perfection of these recipes, become a major economic issue of how they turned useless stuff into commodities of value. And that became then the basis for industrial chemistry as we know it today. And it also then became eventually the basis for definition of electricity in a practical way between metals, and had a whole profound way on the development of sciences in general that was rather independent of the Newtonian notion of force. And of course, we capture this today in the sense of Coulomb's law and that sort of thing. So I just wanted to bring that out because it's that historical part of the chemical language that is in such deep conflict with the laws of physics.
Let me respond a little bit and summarize. I think our session, this one and the previous one in November, triggered by Najee's little model, I think it represents our interests of nailing down or developing some kind of a general cognition model. The challenge is, I call this challenge the losing of our hands. What does that mean? In English phrase we have, you are losing your mind. That means you're going crazy. But if you look at the slogan of Club of Remy, we say we are the international intellectual coffee bar. That the OTA, which means observer, thinker, actioner, getting together to discuss things that are important to us. Now, in the field of physics, which is the earliest, most sophisticated science, or almost our standard, or a lot of other fields want to be in par with the physics. They are actually the easiest enterprise. Why? Because you study an apple and you can handle the apple, yeah? And you study the moon, you can use a telescope to examine the moon very clearly. So those are physics in my hand. In my term, it is a completely handleable field of inquiry. And then we move to chemistry. Okay, chemistry still you have a lot of handledness, like Jerry talked about gold, copper, and iron, and actually, human beings started from copper, right? Because the copper was the first metal that we can make use of it. And then much later comes the iron. So and then you got your table for elements, which every element is kind of you can handle it one way or another. So they are very definite. In Wittgenstein's term, they are all facts. In the word of facts that you can put a map on that, and you can invent a symbol to represent that. So it's a one-to-one correspondence. So early Wittgenstein stream was okay. Let's get everything in order, in logic, and whatever not in logic, we just stop talking about that. So Wittgenstein's earlier mind was that, well, once we get our logic right, then everything will be fine. But later he ran into the problem. Okay, so the later Wittgenstein was completely changed from the earlier Wittgenstein, and he promoted, well, the usefulness for our people to interact, and we survive. We can benefit from this language thing, and so that. But the cost is, as you move from chemistry into biology, and from biology to psychology, and suddenly you have less at your hand. In psychology, you can still do observation, right? And you can still put some label like an introvert, extrovert on people. But if you move on towards the more abstract, when you going into focus on this thing called cognition, how do we know what we know, and how do we play with what we know? You got a lot of abstract language elements there that has no hook, no anchor, no mirror. so what do we do then? So Wittgenstein's proposal was, well, see whether or not your model can help you function better in the world. So in this way, we turn this question back to Nagy. You gave us a proposal for your model, your theory here, and we will ask you how, number one, is this theory make your life better? Of course, you will be very satisfied by yourself by inventing such an interesting, brilliant type of brilliant format of your theory, and that's for your personal benefit. Now, can you give this thing to a user? Like, can you give this to Lauren, give to me, and give it to Jerry, and to make their life better? And that will be a question, biggest challenge to Nagy, in my view, is how do we apply for your theory? So that might be your next step to look into how people can be benefited from this theory. Okay. But as we move into the abstractions and handleless or even the microscope or telescope cannot help, we still can develop something in cybernetics we call models. So you can use the concept of feedback models, feed-forward models to help you to get into more understanding of the complexity in front of us. But overall, I think Jeremy had a very strong presentation and hold in the area of chemistry. Now, how much, to what extent this hold can be pushed into cognition and the manipulation of symbols and the language's terms, concepts, then that will be a very interesting direction to look at, if you agree.
Okay.
Yeah, go ahead.
Okay. I would just say that in the call for papers that I put out, I include reference to a 30-minute video that I gave in June to a computer science group, a computer science community, where I address very directly the question you phrase here, is what is the relationship between symbolic logics? Starting, as I briefly mentioned some time back, the relationship between mathematics, symbols, physical symbols, chemical symbols, biological symbols, and general medical symbols. Now, I purposely do not go into cosmology. I want to deal with things that we have in hand and that we can deal with in the real world. And so I purposely avoid going into the general cosmological, I don't want to use the word bullshit here. There must be a better word, scatological conjectures about cosmology. Okay, so that part is I would just recommend you look at the video, Jason, and tell me if it answers any of your questions. And in that context, I particularly refer back to Frege's notion of abstraction and why Frege's notion of abstraction is irrelevant, or that's not irrelevant. Frege is inadequate to describe the language of chemistry. So you do need a different language of abstraction for chemistry, and that is directly tied to the mathematics of chemistry. So that, but I wanted to hear what Gerard had to say.
Gerard, go ahead.
Okay. There are lots of possibilities in terms of what Jerry was talking about. And while I was listening, I tried to map what he was saying onto some simple system and see whether I could reproduce most of the things that he was talking about. The simple example that I have is the notion of measurements, the notion of length. The usual definition in my world of length is that it is a mapping from a set of objects to a set of numbers, such that the relations between the objects are mirrored, if you wish, in the relations between the numbers. Now, that means that, for example, when you have a set of feet, you can measure them, and the set is measured on a set of numbers, and the numbers and the feet are in correspondence. All the things that he was mentioning about, it is possible, for example, to identify individual feet. Yes, it is. Is it possible to actually have a language? Yes, it is, because it's the language, in this case, of algebra. In that particular language, it is possible to identify lengths. Would there be another language possible? Yes, of course. The language that is being used in identifying the shoes that you need is a different one, even though it is also based on numbers. So the question I have is the whole text that you mentioned, would it be possible to include simply the formal definition of measurement in what you have been saying?
Well, Gerard, I think you cheated and you read the call for papers already.
Well,
that makes sense. No, in the call for abstracts, I address very directly, and I use the term METE, M-E-T-E, which is a Greek or Latin term for the notion of measurement. And the notion of measurement then is meat is different from mode and model in the sense that it is measurement and that it is in terms of the numbers that you use. And that I use Pfefferman's notion of numbers as being foundational to mathematics, as being a
No,
premise.
my question is not about numbers, but about this notion of mapping.
Oh, yeah.
Because numbers are just one part of mathematics, but the table of elements is also a language and it's also a mapping. So that's why I try to ask you about the analogy between the two different types of measurement.
Oh, yes. I'm sorry, I didn't directly. I got on my own wavelength.
Yeah.
Didn't respond to your wavelength. So I very briefly introduce three notions that are related to measurement of the elements or of numbers as atomic numbers of the name of the element. So there's an association between the name of the element, the number of the element, and the parts of the element. In other words, the nucleus and electrons as active agents in the combinatorics of the agency as used in the chemical sense. And so this turns out these can be expressed, number one, in terms of a bipolar number line as a notion of the agency of addition and addition of measurements. Okay, the bipartite two lines, one representing polar opposites, or both of them representing polar opposites as numbers, which gives rise to graph theory and the diagrammatic logic of science. And then thirdly, the notion of the going to the third dimension, if you would, or the third representation of the crystalline form of the material, that is, which has three dimensions to its a spatial object as a composition from the numbers themselves. So it turns out that the mathematics of chemistry or the language of chemistry is just a different form, slightly modified notion of how one views the geometry of the line, how one views the relationships between numbers in terms of the graph direction, which is translated in chemistry into the chemical structure. And then finally, the crystalline forms of the material object in the world, which is what gives order and relationships to the entire system in terms of the facticity of what you're dealing with in the world. So that is a very, very quick overview of a novel mathematics.
So your answer to my question is yes.
The question is yes.
Yes.
The question was, if you wish to repeat it.
Pardon?
The question was, is the measurement, and measurement I understand is a very wide area. It's naming with the names in a particular type of language. Is measurement part of the type of examples that you have given, or is the representation in terms of, let us say, sodium or or oxygen, is that particular to chemistry, or is it part of this general system of measurement where the basic operation, the basic gesture, if you wish, is putting together certain types of things in your environment and mapping them onto something else? That was the question.
Yeah. Okay. Let me repeat then what I said. This is not a cosmological system of measurements.
No. I'm talking about what we do.
Oh, It is a very restrictive language on which you can invoke it if and only if you can do an analysis of material substance to determine what the nature of the object is. So if you cannot do a chemical analysis of the material in some sense or another, the logic does not apply. So all of the premises of the mathematics depend on first the definition of atomicity. And any measurements that you come from are going to be measurements related to atomicity. And so the conceptual groundstone for the measurements is atomicity and how you can relate to those. And it turns out in the practice of medicine, okay, you have various measurements of atomicity, which are useful. So, but you have to be very, very cautious now about what you mean by the notion of a logical relationship.
Oh,
and this
when
those
I talk about logical relationships, I'm very suspicious of those. No, I'm thinking about the way I was talking about the way you are thinking. Is it related to this general type of measurement thinking? And as far as I understand, your answer is yes.
well, I would be very, very cautious in that,
Okay.
in that area of how one interprets the language. As far as general logic is concerned, and the notion of the symbolic logic as widely published in the academic world.
Jerry, maybe you can propose a new date that will have you comprehensively represent what you want to present to us. When you think you can do that? Give me a date.
6 weeks.
6 weeks from today.
I've committed to submitting the grounding paper for the call for abstract from the call for papers to the publisher in 6 weeks. And so
it's about the end of February, right?
Yeah, end of February, 1st of March, somewhere in there. Yeah.
But, early March. Okay, yeah. Early March. Robert, how about you? When are you going to ready to do the session you propose? Robert, are you there?
Yeah, I would say February or March. Maybe.
Yeah, let me know the date. Pick up a Wednesday because we scheduled all Wednesdays for the sessions.
Yeah,
I'm not able right now to I'm not able right now to say when because of other commitments. But I will put my mind to it.
You send me the email and your abstract and the call for participation, and we decide a date. That's no problem. Jerry?
Yeah, I want to finish my answer to Gerard because he and I go way back.
You're fine. Okay.
Oh, no. We're it's more like this.
Oh, okay.
But we've been friends for many, many years, and it's been a wonderful relationship. I've learned so much from him. He's certainly a world-class scholar and one of the best logicians in the world that I've ever met. Okay, so let me just say I have great admiration for his work and his temperament, and that. So within that context, so I wanted to be complete and
I reciprocate. Yes,
I wanted to be complete and say that I have been studying basically logic for the last 15 years, almost exclusively, and because I found that the logic of chemistry is so remote from the logic of mathematics and physics, classical mathematics and classical physics. All right, and it also, yet the logic of chemistry is absolutely necessary for the practice of medicine, for the practice of nutrition, for the practice of pharmacology and toxicology, ecology, and all of these, are dependent on the logic of chemistry. And so there's this strong divergence between the logics, formal classical logic, which is used in mathematics and, if you would, set theory in physics, and the table of elements. There's a tremendous divergence. And so that's why I agree with Gerard with regard to the nature of logic. The nature of logic as given in academic textbooks is just unrelated to reality. And the way they dodge around these issues is through two particular terms: the notion of logical completeness and the notion of logical solidness. And so that's where the